Okay, because we're running out of time, I'm skipping to chapter 3. So this is page 171, chapter 3, lesson 1. And I'm going to try to do a couple lessons actually in this. Okay, so first, this section is asking if something is linear. Okay, so is the relationship between the two quantities linear? If it is linear, we need to find a constant if it has a constant rate of change. So again, if we have a table from 6 to 12, so 12 minus 6, we would have to add 6. And then from 8 to 12, or from 12 to 18, 18 minus 12 would also give us a plus 6. And then we would do the other side. So this is 10 minus 5, or 5 to 10. We would have to add 5. And then 10 to 15, we would also have to add 5. So this one is clearly linear because it has the same ratio of the change in y divided by the change in x, divided by the change in x. This is my change in x. This is my change in y. So if this number divided by this one, 6 divided by 5, is the same as all of the ratios, so 6 divided by 5 would be the same thing. It is linear. So this one is linear. My rate of change is 6 over 5. And then that's all it would have to do. It says, if not, explain your reasoning. But this one is, and so we don't have to look at this if not. All right, the second one is the same type. It wants to know if it's linear. And if it is, we find the rate of change or the slope. Remember that rate of change is the same thing as slope. Anytime it says rate, rates are the same thing as slope. It doesn't actually even matter pretty much by this point. If it says rate, they want you to find the slope. Okay, so on a graph, if it is easy for you to do a table, you can make a table from the graph. Okay, so if I make a table of the x and y values from this graph, my first point is right here. This is at 0 for the x, and this is 3,000, so this is 3,500. So I have 0, 3, 5, 0, 0. This one is at 2, 3,000. And this one is at 6, 2,000. Okay, so now I have a table and I can make, I can find the rate of change here also to see if it is linear. So right here, I'm subtracting 500. And then I'm subtracting 1,000. Okay, so this is different, but if the ratio is the same, it will still be linear. So let's find over here, plus 2. This one is plus 4. So let's find the ratio. Minus 500 divided by 2. Negative 500 divided by 2 gives me negative 250. The other one is negative 1,000. Negative 1,000 divided by positive 4, which also gives me negative 250. So because both of these are the same, all of my rate of changes, change in y divided by change in x, are the same. My slope or my constant rate of change is this negative 250, and it is linear. So I would put linear, and my rate of change is negative 250. Okay, and then again, I don't have to look at this if not because it is. Last one says determine whether it's a proportional relationship. So linear is a constant rate of change when we find the differences on the x and the y. Proportional, if it is proportional, I take the y divided by the x, and it would give me the same number every time. So if I do 6 divided by 5, and 12 divided by 10, and 18 divided by 15, If all three of these give me the same thing, then it is proportional. So this one is 6 divided by 5, which is 1.2. 12 divided by 10 is also 1.2. And then 18 divided by 15 is also 1.2. Okay, so because all of these are the same, the y value divided by the x, it is proportional. So I would put yes, it is proportional, or I could put proportional. And it says explain your reasoning. I would either show all of this, or I could also write because y divided by x is the same. And that's all I need to write, because y divided by x is the same, and I'm finished. This one is proportional, and I could just do it that way. Okay, this next one is not going to be proportional, because if I do 300 or 3,500 divided by 0, that gives me 0. And that's not the same thing as 3,000 divided by 2. Also, to be proportional, it has to go through 0, 0, and this one does not. So this one would not be proportional because the y divided by the x is different every time. Okay,